Hey everyone, today we're diving into a really interesting molecule, carbon tetrachloride, or CCl4. You might have heard of it, especially since it was used to be pretty common in industrial applications. But did you know there's more to this molecule than just its history?
Exactly. CCl4 is one of those molecules that's been phased out in many industries because of health and environmental concerns. But there's a lot to learn from its structure and properties, so let's start with its covalent bonding.
Carbon tetrachloride consists of one carbon atom bonded to four chlorine atoms. The carbon and chlorine atoms form covalent bonds, meaning they share electrons. Since chlorine is more electronegative than carbon, with CCl bond pair is polar, with chlorine pulling the shared electrons closer to itself, but we'll get back to that in a minute.
Right. Let's break it down a bit more. Carbon has 4 valence electrons and chlorine has 7. So carbon shares 1 electron with each chlorine, forming 4 singular bonds.
That's right. If we look at the Lewis structure of CCl4, we can see that each chlorine has 3 lone pairs of electrons and carbon has no lone pairs. This gives us a structure where the carbon is in the center surrounded by 4 chlorine atoms.
Now what's really cool is how VSEPR theory, that's valence shell electron pair repulsion theory, explains the shape of this molecule. Since carbon has 4 bonds and no lone pairs, the electron pairs around it will spread out as far as possible to minimize repulsion. This results in a tetrahedral shape with bond angles of about 109.5 degrees.
And there's something interesting. Even though CCl bond is polar, the overall molecule is non-polar. This is because the symmetry of the tetrahedral shape causes each dipoles, each bond to cancel each other out.
Exactly. So the bonds themselves are polar, but when you look at the molecules as a whole, it's nonpolar because of the symmetry.
Now, because carbon tetrachloride is nonpolar, the primary type of intermolecular force is holding the molecules together is London dispersion forces. These are relatively weak forces that arise due to temporary shifts in electron density.
Right. Since CCl4 isn't held together by stronger forces like hydrogen bonds or dipole-dipole interactions, the intermolecular forces are weaker, which is why CCl4 evaporates more easier than compared to something like water.
Now, let's talk about 2 physical properties from these weak intermolecular forces. First, carbon tetrachloride has a moderate boiling point of about 76 Fahrenheit. It's not as high as water, but it's still pretty high for a molecule this size.
That's because even though the forces are weak, it still takes some energy to overcome them and get the molecules to move apart. The boiling point tells us that it requires moderate amount of energy to break those dispersion forces.
Second, CCl has a high density, about 1.59 grams per cubic centimeter. That's pretty dense for a molecule that doesn't have any strong intermolecular forces. It's mainly due to the large chlorine atoms and the overall mass of the whole molecule.
Yeah, it's a good example of how molecular mass can affect density. Even though the forces between the molecules are weak, the size of the atoms still play a big role.
Thanks for watching! If you like this video, don't forget to hit the like button. If you have questions, leave them in the comments.
Yes!
We'll see you next time. Say see you soon.
See you soon!
Bye!